Continuing with section 2.1, I hope you guys were able to work out these problems. So we had done the A and the B. Now how to find A, B? I would recommend that always start by writing the two matrices side by side like I have done here. In the first, or the matrix on the left, you can put a horizontal arrow somewhere up here or down here or in the middle, and similarly put a vertical arrow downwards with the second matrix. So it will just to remind you that in the first matrix we will take rows, in the second we will take columns and multiply them. So again, keep an eye on the size of the matrices. So this is 2 by 3 and this is 3 by 2. So these two numbers are same, so we can multiply them or find the product. And the resultant matrix will be of size 2 by 2. So these outer numbers in the size of the matrix that determines the size of the product. So it will be a 2 by 2 matrix. So the first entry, first row, first column. So here I showed the work on the side here. So I took the first row of the first matrix and first column of the second matrix, and I multiplied the entries like this, first with the first, second with the second, and third with the third, and added them. So we get negative 15. So one more time, what we did is, so 1 into 2 is 2, plus negative 1 into negative 2 is negative 2, and then plus negative 3 into 5 is negative 15. So 2 and 2 get cancelled and I'm left with negative 15 that I put here. Now the first row and the second column, which is this position. So how do we get the entry in this position? I'm taking the first row and the second column. So this is the same thing, 1 into 0 is 0, plus negative 1 into negative 3 is 3. Okay, here is a mistake. So negative 1 into negative 3, oh no, it's okay. So it's positive 3, and then plus 3 into 1, 3, so we get 6. That goes in here. In the same way now for the second row, I will start with the second column. So 2, negative 3, 1, this column, and this row, sorry, and the second column. So second row, first column, second row, first column. 2 2s are 4, 3 into 2 is 6, because the negative becomes positive, plus 1 into 5 is 5. So add them, we end up getting 15. In the same way, you can write down the second row and the second column and write down, find out this entry. Once you get used to, you won't have to do this stuff. You should be able to do it orally in your head. For example, how did I get this 10? I said, okay, 2 times 0 here is 0, plus negative 3 times negative 3 is negative positive 9, and then plus 1 times 1 is 1, so 9 plus 1 is 10. That's how I got the BA. Is first thing we have to check, is it possible? So the size here is 3 by 2 and size here is 2 by 3. So yes, we can multiply them and the resultant will be of size 3 by 3. So I didn't do any work over here for that because I did it in my head. So first row, you just need to put one arrow just to see the direction. First row, first column, so I get 2 times 4 is 8, 8 plus 0 is 8. Then first row, second column, so 2 times negative 1 is negative 2 and plus 0, so negative 2. And first row, third column, 2 times 6, 3 is 6 plus 0, so 6. Now second row, first column, so -8 minus 6, so -14. Second row, second column, so negative +2 plus -3, -3, 9. 2 plus 9 is 11. And then second row and third column, so it will be this entry. -2 into 3 is -6 plus -3 into 1 is -1. So -6 plus -3, -9, and so on. Last row, third row here, and the first column. So 20 plus 2, 22, -5 plus -3, -8, and then 15 plus 1, 16. So this is how we multiply the matrices. Now CD. So this is of size 2 by 2. This is of size 2 by 3. So yes, we can multiply because these two are the same. The resultant will be a 2 by 3 matrix. So same technique for horizontally here, for vertically here. So 2 2s are 4 plus 3, 4 plus 3 is 7. Then 2 2s are 4 plus 1, 5. Then 2 2s are 4, -5, so 4 minus 1 is equal to 3. Then second row, the first matrix 0 1, and then so you see we just get the -3, -1, 1 1. So this is the CD. And if we take the transpose of CD, we get CD transpose will be the row, first row became the first column here. Second row became the second column. So size of course has changed. Now it is a 3 by 2 matrix. Then we have to calculate D transpose times C transpose. So I transpose the D and I transpose the C. Now we multiply, I'm getting this. But note here, this is something we just calculated. So this and these are same. And also notice here that if you try to compute C transpose, D transpose, you cannot find this product, or not possible, because the size is 2 by 2 here and the size of D transpose is 3 by 2. So you cannot multiply. So whenever you take the transpose of a product, the result is the product of the transpose but in the reverse order. So this is how we do the computations with the addition and multiplication of matrices.